Demand for GLP-1s could be a boon to firms building life sciences facilities. One such firm is Jacobs Solutions, which estimates that GLP-1s will drive a, get this, $120 billion serviceable, addressable market within the next 4 years. Joining us now is the CEO of Jacobs Solutions, Bob Pragada. That's a nice estimate. Not getting ahead of yourself at all? You don't think at this point, Bob? I guess we've got, even though we think of it as relatively recent, there is a pretty long history for the mode of how these GLP-1s work, and they do work.
Yeah, and Joe, so you're absolutely correct. These types of facilities, by the way, good morning. And for the record, I also am a Lucky Charms fan as well. I've been eating it my entire life. These facilities are pretty complicated, Joe. We've been in the space for over 70 years. In fact, Dr. Jacobs, before he founded the company in the 40s, was a former Merck employee. So these facilities are really tied to the molecule and everything that needs to go into a clean manufacturing environment that has ingestible drugs. And so as these things go into biologics and everything we're learning from the mRNA type of products, that's been driving the need for our services in engineering and designing these very complex facilities.
I'm just trying to think of what goes into such a facility. Could you describe what? I mean, GLP-1 is different than manufacturing mRNA vaccines, I would imagine. And so you do across the board life sciences.
We do across the board. Vaccines, drug therapies, the full deal. So what goes into these is that it's a pretty complex process where, you know, you're heating, you're transferring molecules, you're using different media in order to generate the therapy, and so each molecule or each drug requires a unique process and a unique structure of the facility. So think new therapy, new facility. And today in the life sciences world, we're seeing more happen than ever has before.
Are there UV lights everywhere, or vacuums, or
there are vacuums? There's UV lights. Yeah, there's it's a process that's deeply rooted into. It's a batch process. So you're producing quite a bit of material, and then you're taking the slim piece that can then be transferred into a drug substance, and then it goes into a delivery module. Some of the film that you have there is an injectable, but also there's tableting form and other different types of drug delivery. So it's a supply chain that's pretty complicated.
Yes, and expensive.
And expensive.
Is it all domestic? Can it be domestic, Bob, or are you have tariff concerns? Are you importing materials from around the world to do this type of stuff?
Our clients are. You know, Joe, during the pandemic, really driven by the lockdown of transportation logistics around the world. Prior to the pandemic, the supply chain for how these materials were synthesized together in a certain location was pretty distributed from the east to the west. During the pandemic, that really started to move west, and big clients started to consolidate their supply chains. So that's already been in process. You know, a lot of these facilities too are centered around big R&D hubs, really centered around academic institutions. So you see a majority of these complex biologics facilities in Europe and in the U.S.
Bob, if I want a totally complex, large protein or enzyme, can you make that for me? Can you design you can design a facility to make one of the most complex molecules? Because some of them are incredibly complex. Or would you do it through, you build facilities that have bacteria making the products for you, or cloning the products for you?
Bacteria, the actual cells from, look at oncology.
Cell models,
oncology,
yeah.
We're actually replicate. So we design the facilities, and our clients manufacture the product. But yeah, these are some pretty high containment type of areas where safety and security of the product is really, really important. Hence the deep domain knowledge around the molecule is really, really important. And then the bricks and sticks, the facility kind of moves around what the process is developing.
It's amazing. Must take years to build some of these facilities.
It does, and then to validate the facility, both FDA as well as EMA in Europe. But what these therapies, because they have a shelf life with regards to the patent life, we've really centered our expertise around speed to market, and hitting that envelope of where our clients are trying to optimize. First of all, the need. These are some life-saving therapies that the need is very, very high. And so we've kind of taken that 4 to 5 year type of timeline down to a couple, and really focused our efforts on the entire life cycle of delivering that asset to the market.
Who else is in this business?
Not too many. There's not, from a publicly traded company standpoint, Joe. It's pretty much just us. There's some private players that are in regionally based. But it's a space where we didn't depart, and we stayed in it for the better part of 70 years.
You work with the government, I can imagine, too. You're going to be, is all funding going to be cut off?
We're not going to get cut off. I think earlier on the show, Joe, you talked about kind of the political narrative. I think Lauren actually mentioned it as well. There's a lot of reactionary things that are happening right now, but these are needs of the world. We're also in the water space, the transportation space, and so infrastructure and advanced facilities. These are generational macro tailwinds that we're seeing. And yes, could there be some tariff and some rebalancing of how the world works? Sure, but as far as the actual need, we've seen that grow over the years. So we're pretty confident that we'll continue delivering, whether it be world-saving therapies or AI data centers, or the ubiquitous world of everything that's going on in critical infrastructure.